that something to this 1/2 power. So let's actually apply this to some numbers. Okay, so if you have something that is a square, then your life is a lot easier for you. We know this answer is going to be 8. The square root of 64 is 8. Where's my using black here? And again, I could apply that same calculus rule and do 64 to the 1/2 and do all that math, but we know we're going to end up with 8 anyway. So let's say we have something that's not so nice, which is the square root of 18. If you were at school and had your TI Inspires, then you can hit, in the calculator mode, I think it's menu and then numbers and then factor, and then you would enter 18. But if you're at home, so let's assume that we're all at home, Google online factoring calculator, and you want to look for solvemymath.com, and then it takes you to a factoring calculator page, and then you would type in something, you would type in 18, and then you hit factor. Depending upon how fast your computer is, it's going to give you that answer. Apparently this is a really hard number. Okay, here we go. So we have 2, and I hope you guys can see that mouse moving. We have 2 and 3 squared. Okay, so we're going to take that information. This is the product square root property. So I can break up 19, and this is essentially what they're doing. They're breaking up 18 into the factors. With a number like 18, we could see that 2 and 9 are going to help us give up the factors of 18. But if you have something like 182, which is our next problem, then the factoring calculator is going to help us out. So take the factors, which is 2 and then 9. So these are 2 factors, and then put each of the factors in its own radical symbol. So I have square root 2 times square root 9, and remember that the radical symbol is a grouping symbol, therefore these 2 are multiplying together to one another. So if I had 2 square root 2 times square root 9, I get square root 18. So from here, I'm going to apply those calculus rules. And the only thing that works here is the square root 9. I cannot do, I don't have that perfect factor in square root 2, but I do have square root 9. So square root of 9 is going to be 3. Parentheses. And then the square root of 2 is just going to be square root 2. And all along in math, you will see the number go outside of any radical symbol, just like you see the number go before any variable, like a coefficient. So my final answer, I would write this as 3 times square root 2, and that's my final answer, and I box this up. And I'm ready to go on to the next one. Okay, so with my square root 182, go back over to my factor. Okay, so here I have 2, 7, and 13. I notice that there are no squares. So that makes life easier for me. If there are no squares, if it just reports back to me as square root 2 square root 7 and square root 13, that means nothing is going to be perfect, and so my final answer is going to be exactly what I started with. What I'm looking for in a simplification is something squared or something raised to a higher power other than 1. And we'll get that with the next problem, which is 72. But I wanted to show different cases. So here we have something that's perfect, and I know the answer immediately. Here I have an answer that's not perfect and an answer that is perfect, and I get this answer here. I get something where I can't do anything with it. And then last problem, as far as just numbers go, is 72. Okay, and I get 2 cubed and 3 squared. So going back over here, here we go. Okay, so I'm going to write 2 cubed and 3 squared. And I'm going to start to work with these two numbers here. Now I could multiply 3 times 3 to get 9, square root 9, which is equal to, again, 3. But I want to go back to this calculus rule because this is the main reason why I showed you this. If I recognize that any square root is being raised to the 1/2 power, then squares become really nice for me. Remember, the inverse operation of a square is a square root. So if I have 3 squared, and that's inside my radical symbol, then I'm going to have 3. Oop, not square root. 3 is going to be being multiplied by my 2 cubed. Now what do we do with this 2 cubed? Because again, I don't want to work with odd exponents when I'm doing simplifying radical expressions. So what I can do, though, is break it down into something that becomes even. So I want to take something, and you can apply this to any odd exponent. You just subtract 1. So 2 squared, and make sure you're putting your radical symbols up, multiplied by 2 square root 1, and then these are all being multiplied by 3. So remember, using the product property rule, if I did 2 squared times 2 to the first, I would get the original 2 cubed. Okay? But the reason I want to break it down into an even exponent is because I can apply the inverse operation. And so now I'm going to be left with 2 is going to be multiplied by 2 to the first square root times 3. And again, I want to pull those numbers to the front. So 2 is going to be multiplied by 3 oops, not equal. And then what's left over is that square root 2. And I do not have to add the 1 because it's the same thing as 2 to the first. And so my final answer is going to be 6 square root 2. Okay, and if you're really savvy with your factors, you could have recognized that I can do 36 times 2. So let me do that in a different color. I could have done 36 square root and 2 and then 36 square root of 36 is going to be 6, so 6 square root 2 is going to be my final answer in either case. But again, this method is for people who are not so quick on the draw with their factoring. As long as you can take the time to just plug things correctly into your calculator, you can get the right answer each time. So with this next one, fractions are going to be applied the same exact way. You just have to do 2 problems in one. So if I have 3 over 36, the first thing I want to do, the first thing I want to do is reduce my fraction. And if you reduce your fraction, in this case, let's not reduce the fraction because you'll get into simplifying or rationalizing the denominator, and that's not what the point of this lesson. So let's apply this if 3 did not go into 36 evenly. So like I said earlier, you need to do 2 square root problems in one. So square root 3 and square root 36. So square root 3 can't do anything with, so it stays. Square root 36 is going to be 6. And that's my answer. Over here again, I'm going to break it down into 2 problems. I'm going to go square root 4 and I'm going to go square root 25. Which is going to get me 2 over 5. Okay, if you are on your holt